Okay, here we have problem PA4-3. This is accounting 202. Um, and the topic of this chapter is ABC costing. Uh, this is good stuff. It's kind of it's very closely related to what we did in chapter 2 with job costing, where we have a situation where we have products that include direct material cost, direct labor cost, and overhead cost. And so let's take a look at it. And the beginning part of the problem asks us to calculate overhead allocation between two different product lines, the home model and the work model, using traditional costing. And then as after you work past the first couple of requirements, then we get into ABC costing. So let's take a look at this. First of all, I think it's very important that you understand that setting up your problem is uh, half the solution or more. It really is. And so what you need to do is, as I've done here, I've gotten kind of a head start on it, but that's okay because I can explain what I've done. But for the most part, as you can tell, I've just recreated the same information that's in the problem. So we have direct material cost per unit, direct labor cost per unit, and shown between the home product and the work product. So I've included that information here on my worksheet. Sales price per unit is shown here, and I've already made a space here because I'm going to insert additional information. I wonder if you can guess what that is I'm going to put in here. But anyway, going back to the problem here, expected production per month, and I show that here for each of the two products, home and work. And then we have total overhead. So the total overhead is 188,010, and they show the overhead divided up by cost pools. Now it's important to understand that this concept, cost pools, is something new to ABC costing. Okay, we haven't used cost pools prior to studying ABC costing. And what ABC does is basically provide a better method or better methodology to use for allocating overhead costs to products. Because just as we did in chapter 2 with jobs, I think you recall that your overhead is kind of a big lump or a big chunk of costs, manufacturing costs. And of course, it depends on what your products are, what your manufacturing system looks like. But ultimately, all of those costs to make a product that are not direct materials or direct labor go into overhead. So, overhead would include such things as indirect materials and also indirect labor, and then all of the other manufacturing costs that are part of the manufacturing process. Some examples would be factory rent, factory utilities, factory maintenance, factory supplies, factory this and factory that, etc., etc., etc. And the fact that each of those cost or expense categories, each of those names is preceded by the term factory tells us that those costs or expenses are quote unquote factory or manufacturing costs. So those are the costs that we initially lump into this big chunk of cost and call it overhead. So the trick in any manufacturing operation is to allocate your overhead to all the products that you make. And you want to be able to do that in the best possible fashion, because it's important that each of your products, be it jobs or any kind of product really that is being manufactured by the company, it's important that it reflects as accurate a cost total as possible. Now, why is it so important that you have an accurate cost total for each of your products? Well, if you thought about it for a second, I think you'd agree that for one thing, aside from the accounting aspects of it, accounting aspects would simply tell us, well, whatever it takes in the way of cost to make a product, we need to be able to account for it accurately. That's always true. But more of a just a general business perspective, it's important for us to know what our cost is so that we can accurately and fairly set our price. A good example is a plate lunch. Uh, Back when I was a kid, you could get a plate lunch for $1.25. Nowadays, a plate lunch might run, 6, 7, $8, maybe $10 on the high side, $5 if you're really lucky. But whatever it is, let's say you got a $8 plate lunch. How in the world do you set that price, $8 for that plate lunch? Well, what you really need to be able to do is cost that plate. So let's say you got some terry beef, maybe some katsu chicken, and rice, and potato mac salad, and maybe a little bit of nishime cucumber or whatever. Whatever it is you got on that plate, you got to have some system in place for you to be able to put a cost total on that plate. And so let's say the cost total for that plate that I just described is $4. And so $8, if that's your price, then it would simply be a matter of doubling your cost. Of course, another consideration anytime you're wanting to set price for what you sell is what the competition is doing and how your product stacks up or compares to the competition. So, there's a lot of things that need to be considered anytime you're doing this kind of work. So that's kind of a long-winded explanation of why overhead allocation can be so important. And so ABC costing basically gives us a better, more accurate way to allocate overhead to our products. And one of the tools that we use with ABC is what we call we divide up our overhead costs into what we call cost pools. And then for each cost pool, for instance, in this problem, we have 3 cost pools: setup, quality control, and maintenance. And this distribution here is based on some reasonable, logical, and hopefully accurate methodology. So we divide up our total overhead into the 3 cost pools, and then, very importantly, for each of the cost pools, we have to decide on what we call a cost driver. In other words, what activity in the organization, in the manufacture of our products, is the best measure for that cost that we need to allocate. And we call those measures cost drivers. So To allocate our setup costs, we're going to look at the number of setups. To allocate our quality control costs, we're going to look at the number of inspections done. And finally, to allocate our maintenance costs, we're going to look at the number of machine hours. And I think the assumption there is that it looks as though our product requires some sort of automated process with machines, and generally the more you use any machine, the more maintenance it's going to require. And so that would be one way to uh, approach allocating maintenance costs based on the number of machine hours. I think that makes sense. So we have again our cost pools set up, and the total is equal to our total overhead. And so what I've done here is just show those amounts separately. And then finally, for the cost drivers, um, I've also shown that information over here on the spreadsheet. Now, what I did do uh, on the spreadsheet was I added totals. Oh, I'm sorry. The totals were already here. They're given in the problem. So we have the cost drivers broken up between home product and work product, and also with a column for the totals. Um, okay, now so basically, this information here that I have painted in on my spreadsheet is information that's all in the problem. It's just that I want to put it on a piece of paper, spread it out, because I know for the most part I'm going to be using all or most of this data to come up with the answers to the questions in the problem. Okay, and I hope that makes sense. The data given is what you're going to have to use to come up with your problem solution. So let's take a look um, at number one. It says, suppose Harbor uses a traditional costing system. So the first question basically is saying, okay, forget ABC. We're just looking at traditional costing. And for their traditional costing example, they're saying machine hours is the cost driver. So what we do here is look at the machine hours given in the problem. So for the home product, it's 1100. For the work product, it's 2200. Total is 3300. And the question here is asking if we're using a traditional costing system with machine hours as a cost driver, what would be the amount of overhead assigned to each of the two product lines, home and work? And so what we do is get a percentage or a weighted average for each of the two product lines for machine hours for each of those two product lines. So here we are. This calculation is based on this formula, D31 divided by C31, and so that is the total machine hours for home divided by the total. And this calculation is F1 divided by C1, so the total machine hours for work divided by the total. And as you can see, the results are 33% and 67%. If we were to change the decimals into percentages, that's what it would come out to be, 33.33% and 66.67%. So it doesn't matter if we leave them as decimals or show them as percentages. The number is the same. And then we multiply by the total overhead, the 188,010, against both percentages to come up with the distribution of our total overhead between our two products, and again based on traditional costing using machine hours as a cost driver. Now what I've done over here is I've already inputted those amounts here as the answers for number one, and we can check our work and we can see that we're okay. Okay, now let's go to number two, and let's see. It says calculate the production cost per unit for each of Harbor's products under a traditional costing system. Now, when we look at production cost per unit, we need to include direct material, direct labor, and overhead. So this is where I was right on number two when I opened up this space in my worksheet. And so what do you think I'm going to put in here? Well, you're right, it's overhead per unit. And of course, we're going to have to figure out the overhead per unit based on our traditional costing system. So if we go down to the calculation that we just did a few minutes ago, we calculated overhead under the traditional costing system using machine hours as the cost driver. Our overhead allocation to home, let me put a different color on that. Our overhead allocation for home would be, here we go, would be 62,670, and our overhead allocation for work, again based on traditional costing with machine hours as the cost driver, our overhead allocation in total would be 125,340. And then to get the per unit amount, we use expected production per month. Remember that this overhead estimate 188,010 is per month. So we would take the total allocated overhead and divided by the estimated total production for each of the two products. And I think we can just copy that formula over, and that looks a little big, but let's see, that's F35 divided by F13. We got F35 divided by F13. Yeah, we're correct. So our direct material, direct labor, plus overhead per unit, and maybe we need to open up one more, maybe a couple more spaces there so that we can show our total cost per unit would then be the total of our material, labor, and overhead. And so we should be able to add those three up and copy that formula over, and let's see if those are our correct answers, 141 and 381. So we want to put 141, and let's see, it's telling us 2 decimal places required. Okay, so we need to show these amounts at 2 decimal places. Okay, here we go. So it's not 141, it's 140.56. And for work, it's 380.86. And of course, the proof is always in the pudding. We got to check our work and cross your fingers and pray to the Lord that your answers are correct. And lo and behold, they're correct. Okay, so we're lucky so far. Okay, um, now we got 8 different requirements here, so I think I'm gonna have to divide this problem solution up into maybe 2 or 3 videos. Uh, let's do one more because the third one is also a, a requirement that uses the traditional costing system, and then from 4 to the end, we're switching over to ABC. Okay, so for number 3, it says calculate Harbor's gross margin per unit. Well, what's gross margin? Well, then the logical next question is what is gross profit? And I think we know by now that gross profit is net sales minus cost of goods sold. And so gross margin is a very similar uh, type of calculation and we use that terminology more in a manufacturing type of situation or setting. And so our gross margin would be our selling price per unit and subtracting our selling price per unit less our total cost per unit. And let's see if that's going to work for us. Let's add a couple more. Oops, that was the wrong one. Uh, we want to add a couple more sheet rows. There we go. And so let's put in, let's see, gross margin per unit. And again, what we need to do here is take our selling price and subtract our cost. And I think we should be able to copy that formula over. And let's see if those two answers are going to work for us. Okay, so for home we got 224.44. And for work we got 201.14. Oops. I need to switch over. 201.14. And again, we need to go down to the bottom, check my work, cross our fingers, pray to the Lord, and we're lucky again. Those answers work. So, at this point in time, I'm going to stop, and as you can see, our worksheet has the information that that shows how we got our answers, and our problem sheet here shows that for the first 3 requirements our numbers are okay. I can't get the whole thing. I can't get the whole thing to show. That's just about it right there. Yeah, I think that's all of the information. Oops. So what I'll do is stop the video and upload it to YouTube and send it out to all of you students, okay? And I'm gonna have to be leaving in about an hour. I got a 3-hour class tonight at the college, and I'll be back after 9, and so I'll see what questions you guys might have between now and then, and we can go from there. All right. Hopefully this helps, and um, uh, we'll talk to you guys soon. Aloha.